Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph linear inequalities when you have them in slope-intercept form. So graphing linear inequalities, I'm only doing 4 examples in this case because graphing linear inequalities is very, very similar to graphing linear equation. And basically, if you want to go ahead and graph the line, one of the easiest things to do is just think of this as graphing a linear equation. And a lot of times what we do is, especially when students are having trouble, wrapping their brain kind of around this, we just rewrite the inequality as an equation and then graph it as we would. Now, remember when you're graphing, equations or even inequalities, that basically when we have it in slope-intercept form, I'm just going to write the slope-intercept equation. We have y equals mx plus b. You can see that all of my inequalities are in this form, except for the equation has been replaced with a inequality, or the equal sign has been replaced with an inequality. But the main important thing to understand about this is, what does m and b represent? Remember, m represents the slope, and b represents the y-intercept. Now, these are totally different parts of the line, where the slope is a ratio. It's the change in the y-coordinates over the change of any two x-coordinates between any 2 points given on the line. Also, a lot of really commonly known as rise over run, where the y-intercept is the point where the graph crosses the y-axis. And that is a coordinate point where x is 0 and b is going to be the value, because the y-intercept, the x value is always going to be 0. OK, so just make sure we understand that when we get into graphing, because basically when we're going to graph an inequality, we're going to graph it just like an equation, as I said, but we're going to identify the slope, we're going to identify the y-intercept, then use the slope to find 2 different points. Now, with an inequality, it's very, very important to be able to understand, now we have to include shading. And we also have to include, does the line, which we're now going to call the boundary line, is that included in the solution or not? So the first problem, or the first 2, I'm going to show using a test point to kind of prove why it works. And then for the last 2, we'll kind of go through some obvious things, hopefully, that you remember as far as determining if it's included or not. So the first thing we need to do, though, is find the y-intercept. So you can see that my y-intercept here is 1. So I'm going to go up to 1 and make a nice big dot. Then you can see that my slope here is written as a whole number. So to rewrite it as a ratio, I'm going to put it over 1. So right now I have -2 over 1. So basically that slope is going to tell me to go down 2 units over 1. And then I can create my next 2 points. So down 2 over 1. You could also go up 2 and then to the left 1. That would work as well. OK? But now, if this was an equation, we would just write the line in there. But if the line is a part of the solution, then it's going to be exactly the same. But if the line is not a part of the solution, then we're going to draw a dashed line. So how do we determine if it's a part of the solution or not? Well, what we can do is use a test point. And basically what we're going to do is we're going to choose a point on the line. I'm going to choose the point 0, 1, because that's the y-intercept. Then what you're going to do is plug in 0 in for x and 1 in for y, and see if it makes the equation true. So I plug in 1 is less than or equal to -2 times 0 plus 1. And what I get is 1 is less than or equal to 1, which is true. So since my point on the line is true, that means my point is a part of the solution, or my line is going to be a part of the solution. So I'm going to draw a nice line that's going to include. So all the points on this line are going to be true. Now, the next thing we want to do is determine, well, what about the points that are not on the line? The points below it or the points above it, are those a part of the solution? And again, the best way to double check your work and to see is to choose another test point. Now, when you're testing the points below or above the line, it's important to choose a point that's not on the line. So if the line goes through 0, 0, you can't choose 0, 0. But otherwise, 0, 0 is the best line, or best test point I like to do as far as determining the truth below or above. So you can see my point 0, 0 is below the line. If this point is true, when I plug it in for y or for x, that means all the other points are true. If it's false, that means all the points below are false and all the points above are true. So now I'm just going to test 0, 0. So I plug a 0 in for x, or for y and for x. And I get 0 is less than or equal to 1. Well, that again is true. So since this point is true and it's below the line, that means all the points below the line are going to be true. OK? All right, so now let's go and get into this one. I have y is less than 3x plus 2. So again, first thing we want to do is identify the y-intercept, which is going to be 1, 2. Then we're going to use the slope. Again, we're going to rewrite our slope as a fraction. So that's going to tell me up 3 over 1. Now you can see as I kind of go up here, I can say, oh, I'm getting a problem here. I can't, you can continue the graph up 3 over 1. But remember, you can also rewrite this as negative 3 over negative 1, right? Because negative 3 over negative 1 is the same thing as positive 3 over positive 1. The negatives divide to a positive. So what I'm going to do is I'm going to go down 3, 1, 2, 3, and then to the left 1. And that's still going to produce my same point, 1, 2, 3, my same point where it would be up there. OK? Now, again, we want to go ahead and test to determine if our point is if our boundary line is a part of our solution or not. So again, I'll choose a point, and I'll do test. And I'll choose the point 0, 2. So I'll plug in 2 in for y and 0 in for x. And what I get is 2 is less than 2. Well, 2 is not less than 2. 2 is equal to 2. So therefore, that is false. So when you have a false test point, what you're going to do is create a dashed line. So the dashed boundary line is still going to, the boundary line is still going to separate the true points and the false points. But the points on the line are not going to be a part of the solution. Then we can also test our test point. So then I'll test 0, 0. Since my test point is not on the line, I'm going to choose 0, 0. So I'll do 0 is less than 3 times 0 plus 2. 0 is less than 2. Well, is 0 less than 2? Yep, that is true. So therefore, all the points that are now below this line to the right are also all going to be true. So I'm going to shade those solutions to represent that. Now, using test points is very helpful. But it's not the only way, or not always the most efficient way to be able to do this. I like using test points to, one, check my answer, and to see why it makes sense. Because you could choose any, you don't have to choose 0, 0. You could choose any point below here, and it'd make it true. And if you picked any point over here, it would make the inequality false. So it's very helpful to understand that. But once you get to understand that, let's kind of get into, let's move it forward a little bit quicker. So that's what I'll do for these next two examples. Now, now you can see that the only difference between these examples and these examples is, besides the inequality symbol is now greater than, my fraction, my slope is already a fraction. So I don't have to rewrite it over 1. But as far as the graphing, the process, it's going to be exactly the same. I'm going to go to my, and the y-intercepts are negative. So now I'm going to go down to negative 1. Now my slope is 3 over 4. So that's going to tell me go up 3, 1, 2, 3, over 4. 1, 2, 3, 4. OK? Now, instead of using a test point, what I want you to understand is whenever you have an inequality symbol that's greater than or less than, that means it's not going to be a part of the solution. So that's going to tell you it's a dashed line. And the way I like to relate that is, remember when we were graphing one variable inequalities on the number line? Whenever it was less than or greater than, that left us with an open circle, the open dot. So that means it was not a part of the solution. Anytime it was less than or equal to or greater than or equal to, we filled in that dot, meaning it was a part of the solution. So when you have less than or greater than, you're going to use a dashed line. When you have less than or equal to or greater than or equal to, you're going to use a solid line because it's a part of the solution. Now, the other thing is, when you're graphing in slope-intercept form, that's why I like putting it in slope-intercept form. As long as your y is on the left-hand side, okay, then you can determine where the shading is going to be. You can always use test points, and test points are very, very important to make sure you check your work, especially if you're not really sure about this. However, this is saying y is greater than everything over here. So if you look at the y coordinates, like the y-axis, all points that are going to be greater on the y are going to be above the line. So therefore, I am going to shade above the line, because the y coordinates are greater than above this line. So there's going to be above. Again, you could always use a test point. If you use 0, 0, you'd have 0 is greater than negative 1, which is true, so you'd shade above. So now, let's go and get into this one. So this one goes down to negative 2. OK, now we have a negative slope. Please note that negative 2/3 is equivalent to negative 2 over 3, which is equal to 2 over negative 3. Think about it this way. Negative 8 over 2 is equal to negative 8 over 2, which is equal to 8 over negative 2, which is all equal to negative 4. So it doesn't matter where the negative sign is, numerator or denominator. So the reason why I tell you that is because you can either go up to the left 3, 1, 2, 3, or you could go down to the right 3, 1, 2, 3. And you can see that when I plot these points, they're all going to lie on that same line. This is greater than or equal to, so it's going to be a solid boundary line. Then my inequality symbol here is greater than or equal to. So again, that's going to be points that are greater than or above. The y-coordinate are going to be greater above the line. Again, if you use the test point 0, 0, since it's not on a line, it would be 0 is greater than or equal to. That goes to 0. 0 is greater than or equal to -2, which is true. So I'm just going to represent these lines as my shading. So there you go, ladies and gentlemen. That is how you graph a linear inequality when in slope-intercept form. Thanks.